In this video we are going to talk about prime counting function. So let's have a number n which belongs to the set of positive integers except 1. So for n equals 2, p of 2, which means how many numbers less than 2 are primes, is 0. For n equals 3, what is going to be p of 3? It means how many prime numbers do we have that are less than 3 is just 1 prime, which is the 2. The first the prime number, or the first even number 2, is basically a prime number. For n is equal to 4, pi of 4 is gonna be 2, because we have just 2 and 3 as primes. For n, where n is the integer 5, p of 5 is going to be what? Again, how we want to count the number of primes that are less than 5. How many we have? We have 2, 3, 4 is not a prime, so we just have 2. For n equals 6, p of 6, how many primes we have less than 6? We have 2, 3, and 5, so p of 6 is 3. For n is equal to 7, p of 7 is, again, 2, 3, and 5. 6 is not a prime number because it has also 2 and 3 as factors. P of 7 is 3. For n equals 8, p of 8 is what? 2, 3, 5, and 7. So we have 4 prime numbers. For n equals 9, p of 9 is gonna be again 2, 3, 5, 7. So it's gonna be 4. For n equals 10, p of 10, we have 2, 3, 5, 7. So it's gonna be 4. For n is equal to 11, p of 11 is gonna be 2, 3, 5, and 7. It's gonna be 4. For n equals 12, p of 12 is going to be 2, 3, 5, 7, and 11. These are the primes, so we have 5. For n equals 13, p of 13, again, we want to count how many primes are less than 13, so it's going to be 2, 3, 5, 7, 11, so again it's 5. For n equals 14, p 14 is going to be 2, 3, 5, 7, 11, and 13. So we have 6 primes. So that's the idea, basically. The whole idea: we have a positive integer, n equals 2. We want to find how many primes are less than 2 is 0, because 1 is not a prime number. Then for n equals 3, how many primes do we have that are less than 3 is just 1 prime. For n equals 4, how many primes do we have? For the numbers that follow before 4, so it's 2 and 3. For n equals 5, numbers that are less than 5 and they are prime numbers, 2 and 3. For n equals 6, 3, and so on. And you can draw a graph. So you have 0, 1, 2, 3, 4, 5, 6, 7, and so on. So that's the positive integers, and that's P of n. So of course P of 2 is 0. P of 3 is going to be 1. P of 3 is going to be 1. P of 4 is going to be 2. P of 5 is going to be 2. And so on, and so on. So you can describe this by a Heaviside function, and you can plot all these values, and as you go up things become more complicated because it's not easy to count how many primes you have, and so we have to use different machinery to find approximations. We can find a continuous function of logarithmic type that involving natural logarithm that so it does like something like this, for example. It approximates this this discrete graph. So that's the famous prime counting function, and Ramanujan was a mathematician who has worked on number theory and has proved some kind of inequalities for the prime counting function.